and welcome to Knative Eventing 101. My name is Akash, and I'm an engineering manager at Google. I have with me Chen, who is an engineer at Google, and we both work on Knative Eventing. This is a beginner level session, and we'll introduce you to Knative Eventing concepts. So here's what we are going to cover today. We'll start with the rise of microservices architectures and some of the issues inherent in them. Then we'll go over event-driven architectures and address some of those issues that we have introduced. We'll then show you how Knative Eventing fits into all of this. Then we'll give you a demo of an event-driven application built using Knative that does some sentiment analysis on a complex image. We'll then follow it up with a deep dive into the application architecture while introducing the core concepts of eventing. Finally, we'll introduce to a vibrant community of developers. So first, let's talk about the rise of microservices. In the early days, we saw large applications architected as monoliths. In early 2000, we saw a rise of service-oriented architectures, but they were still built as monoliths. You'll be surprised that even today, many organizations have monoliths. So now, what is a monolith? A monolith is where there is a single application layer, which contains your presentation layer, your business logic, and the database layer, all integrated into a single platform. Take this e-commerce store as an example. All its 5 services run under a single application layer. Even though this looks simple, there are some inherent issues in it. First, as the incoming rate of requests increase, we will require more resources to process and hence scale the application. Now, a monolith can scale in only one direction, and that is vertically. This means we can scale the application over a single machine by adding more and more hardware resources, and there's always a limit to it. Scaling horizontally across machines is hard. As application grows, we will have more services and more teams. It will soon become overwhelming for developers to build and maintain the application codebase. Not just growing the application, but even changing anything will require developers to build, test the entire application, which is going to be a nightmare. To overcome these problems, you could adopt a microservices architecture and start modularizing the application into small standalone services that could be built, deployed, scaled, and maintained independently. We start by pulling 2 of these services and the database out, followed by a few more services. Finally, we have all services independently pulled out. In reality, we'll break these services down into more modular microservices, but for simplicity of this presentation, I have not done so. Now that each service is independent, let's see what are the advantages that we get out of this architecture. First, microservices architecture introduces a concept of separation of concerns. This promotes agile development. Each microservice has its independent code base and is built, maintained, and deployed independently by individual teams. Each team has the flexibility to build the service in the language of their choice and can also update the tech stack with each service independently. On top of all of this, now we can scale our application and each individual service independently, not just vertically, but even horizontally. Now, these are all advantages of a microservices architecture, which is good. But we also need to know about some of the drawbacks that are inherent in this architecture. First, if you look at the figure, we have introduced a spider web of point-to-point integrations. Even though each service's code base is decoupled with its own contract, we have introduced coupling with direct service-to-service communication. Due to this inter-service communication, which is between 2 services, adding or removing a service requires updating upstream as well as downstream dependencies. Now, here is exactly where event-driven microservices come to rescue. But before I go into event-driven microservices architecture, I just wanted to take a step back and take a couple of minutes to go over what exactly an event is. Now, as a software system operates, an occurrence is the capture of a statement of fact. An event is a record expressing that occurrence and its context. An action is executed when it is notified about the occurrence by receiving the event. So in simple words, something happened. We capture that something happened in an event. So the event has the occurrence as well as the context data. And then one or more actions are triggered based on that event. It is important to note that events represent facts, and therefore they do not include the destination. And the producer has no expectation how the event is or will be handled. So now back to event-driven architecture. An event-driven architecture has three main components. First, the event producers. They're exactly what the name says, they produce the events. Second is an intermediary that receives an event and routes it to the next receiver. Now, this next receiver can be another intermediary or it can be a consumer. And that is what the third part is, a consumer. A consumer receives an event and acts on it. It uses the context and the data to execute some logic, which might lead to occurrence of new events. So now you can note that a service can act as a consumer as well as a producer at the same time. So what are the benefits of this architecture? First, the services are now fully decoupled, no point-to-point communication. Producers have no idea about who will consume the event. Consumers just tell the intermediary that they are interested in a specific kind of event and the events just get delivered. This is highly scalable. Now you can extend it organically. Because there is no direct point-to-point communication between producers and consumers, one can add producers and consumers independently. Now, where does Knative Eventing fit into this architectural style? Knative Eventing is an intermediate. It is a set of composable primitives to enable late binding of producers and consumers. But for an intermediary to work for every kind of application, we need to standardize on something. And that's where we have standardized on the event envelope. Knative uses Cloud Event as the event envelope. Cloud Events is a vendor-neutral specification for defining the format of the event. It is a CNCF project. In Knative, we call the producers as event sources. These produce specifically cloud events. This could be your own service producing a cloud event, or it could be a special source such as a GitHub source or a Kafka source that can convert GitHub and Kafka events into cloud events and feed them into a Knative-based application. We'll go over some of these details in later slides. A consumer could be any service that can receive an event. And we'll also go over the details of what defines a consumer later in slides. A broker represents an event mesh. Events are sent to the broker's ingress and then sent to any subscribers that are interested in that event. A trigger is how a services subscribe to the events from a specific broker. Along with the intermediary, we also have events and sources registry. Now, why do we need a registry? Think about examples like client tools trying to list all the sources available on the cluster. Or if you want to find out what are the kind of events available on the cluster, this is where the sources and events registry helps build the user experience around. Broker and trigger are not the only primitives that we have. We have more, such as channels and sequence and parallels, which you can use to stitch together a complex application. We'll go over all these in later part. Okay, so now enough of talking. Let me hand it over to Chen, who will show you Knative in action. Chen, go forward.
Thanks, Akash. Hi, I'm Chen. I'm going to demo a sentiment analysis application. In this demo, I will upload such an image to a Google storage bucket. The application will detect all the faces in the image, like here, extract them out, and determine the emotion for them. We will see the results in the application's webpage soon after I upload the image. Here, I'm on my cloud storage bucket page. At the moment, I have no image uploaded in my bucket. Here is the application's webpage. It's where we will see the final results from the processing. Of course, it's empty at the moment. Now let me upload an image. The exact same image we have seen in the slide before. Okay, done. We should see the result here in a moment. The application will extract all the faces out from the original image and score them individually. Here you can see the result, each phase with their corresponding score. Let's look behind the scene. The application consists of these components. We use the cloud storage bucket to store the images uploaded. We use a Firestore database to store the final results. We have 5 microservices deployed as Knative service on a GKE cluster. Each of them has a different responsibility. The first service is responsible for detecting faces in the original image. Essentially, it will generate the coordinates of the face bounding boxes. Given these coordinates, the second service will extract the face boxes out as separate images. The third service will run the algorithm and generate a motion score for a given face box. And the fourth service is responsible for writing the score to the Firestore database. And the fifth service is for the UI, which reads the results from the database. Now let's look at how these components are connected together. When I uploaded the image to the storage bucket, we have a cloud storage source that imports the cloud storage events to the broker. The first trigger subscribes to such events and trigger the first service, which uses the metadata in the event to retrieve the image and detect the faces bounding boxes. For each face in the original image, it produced a new event back to the broker with the bounding box coordinates. The second trigger subscribed to such events and invoked the second service, which used the coordinates to extract the face boxes as separate images. For each face image, it produced a new event with a reference to the image. The third trigger subscribed to such events and invoked the third service, which output the emotion scoring events. The fourth trigger subscribed to such events and invoked the fourth service that wrote the results to the database. Eventually, the UI loaded the results from the database. As you can see, as a developer, I only need to focus on implementing the services and defining the triggers that invoke them. The broker will take care of the rest of the communication. Now you have seen how these components are connected together. Let me give you a quick peek at what's really happening in the cluster. Here in my terminal, I'm tailing the logs from all the services except the one for the UI. They are in order. This is the first service that detects all the faces. This is the second service that extracts all the face boxes. This is the third one that determines the score, and this is the fourth one that writes the result to the database. Here, let me upload another image, and you will see how they are triggered one after another. The first service got triggered, the second one got triggered, now the third one, and now the fourth one. Here is a clear view of the logs. This is the first service. As we can see, it received a cloud storage event with the reference to the image I just uploaded, and it produced the new events where it has the coordinates of the face boxes. In the second service, it received those events and it produced the new events with extracted face boxes with a reference, such as here. In the third service, it received those previous events and started to determine the sentiment scores. And here, that's one sentiment score for a face box, and it produced such new events. In the fourth service, it received such events and write the data to the database. As mentioned earlier, Knative Eventing provides composable primitives to enable late binding event producers and consumers. So now let's look at those concepts in more details. A Knative Eventing source is a component that generates events or imports events from external producers. The main responsibility of a source is to produce events in a cloud event format, which is the standard format we uniformly adopt in the project. For example, GitHub can be configured to produce a lot of events, but they are not in Cloud Events format. And we have GitHub source that converts them to Cloud Events format. There are a lot of existing sources. Some are community owned, like Kafka core source, GitHub source, as I just mentioned. Some are vendor owned, such as Cloud Storage source, as you have seen in the demo. Trigger Mesh also supports AWS SQS source, etc. You can even write your own custom sources. For example, let's say you have a legacy system that generates events in some legacy formats. You can write a custom source that converts those events into Cloud Events format, and then with Trigger and Broker, you can integrate with the rest of your system. There will be another session that dives deep into Knative sources. Feel free to take a look if you are interested. Broker and Trigger are the main events intermediary in Knative Eventing. You can treat a broker as a black box where you throw events into and use Trigger to subscribe events from it. In a trigger, you can specify filters using Cloud Events attributes so that you only subscribe to events you are interested in. The event sync in a trigger could be any addressable. The addressable here means any resource reference that could be resolved to a URL or just a plain URL. Knative Eventing provides a default broker implementation. There are alternative broker implementations such as GCP PubSub-backed broker, Kafka-based broker, etc. There will be another session that dives deep into broker and trigger. Again, feel free to take a look. Here are some lower-level primitives in Knative Eventing. Channel and subscription are the messaging primitives. A channel is an abstraction of a message transport, which takes care of things like message persistence. And a subscription allows subscribing messages from a specific channel, which takes care of message delivery. There are many implementations for them, such as Kafka, ASQS, Nats, PubSub. The default broker implementation in Knative Eventing uses the messaging primitives. There is another category of primitives called flows. There are sequence and parallel. They both allow invoking a list of services, with the difference intuitively. Sequence will invoke them sequentially, while parallel will invoke them in parallel. They could come in handy for certain use cases. For example, sequence makes it really easy to build an event augmenting flow, where at the beginning of the flow you have a bare minimum event, and in each service in the flow you add additional information to the event, and in the end you have an event with much richer information. The benefit of using a flow is that you can treat it as a unit of work, in which any intermediate events won't be visible from outside. This prevents unexpected events flowing into your system and causing unexpected behavior. A service in a flow is essentially an addressable that could consume events and potentially produce events also. By this definition, a service in a flow could be another flow or something like a broker. You can actually build more complex flows when you combine them. For example, in a parallel, you can invoke a sequence, a broker, and another parallel. Thank you, everyone. Let me hand it back to Akash.
Thank you, Shen. So, as I promised in the beginning of this presentation, that I'll introduce you to our vibrant community of developers. Knative is an open source project under Apache license and has a vibrant community of developers around the globe. Here are a few highlights about our community. We have two core components, serving and eventing. Today, what we introduced you to was eventing. Serving is another core piece that lets you build a microservice in the most simplistic manner and host it in any Kubernetes-based environment. We have 10 active working groups with around 450 contributors. We have more than 15 active repositories. On top of all this development, we have 7 different Knative-based offerings from vendors such as Google, IBM, Red Hat, Trigger Mesh, and VMware. Knative is maintained by the community, which includes organizations such as Google, VMware, SAP, Red Hat, IBM, and a great ecosystem of startups. So, how do you get involved in all of this? You can kick, if you just want to kick the tires, you can start by our docs, and we have some easy quick start examples. If you have questions or you're stuck with anything, reach out to us on Slack. If you have any follow up questions, then please reach out to us on our community Slack channel, or feel free to reach out directly to me or Chen on Twitter or LinkedIn. My Twitter handle is underscore AkashV, and LinkedIn is AkashRV. And Chen's Twitter handle is Chen with 8 O's, and the LinkedIn is CSHOU. Thank you for joining us.